A&B coefficients will study from the emission, the basic of laser. So that day only a little bit explanation only we gave on laser, that is a light amplification by stimulated emission of radiation. Okay, this using the concept of laser and concept of light, we derived the equations, and that equation contains the two constant terms A and B, and this coefficient, we will read what is the name of this A and B, or called as the Einstein coefficients. To find this Einstein coefficients, definitely you should have the knowledge about what is by absorption, what is in by spontaneous emission and stimulated emission. So we all know light can refract and absorbed. Okay, light when it falls on any object, it absorbed and also it emitted. We all know in our lower classes we have studied. During summer we cannot wear the dark color, that is the black color dresses. What is the reason? And we cannot use the black color umbrella. What is the reason? What is the reason of this condition? You should not wear that.
It absorbs more.
It absorbs more radiation. Light and normal light. This is not a normal room light. This is the radiation from the sun. So the dark colors will absorb the maximum light radiation towards it. So light will be absorbed and also emitted. What is the meaning of emission? Emission means? The simple meaning of emission. Releases. That's all. Releasing. Emission na absorbன்றது ஒரு inputனா emissionன்றது output. That's all. Absorb பண்ணி release பண்ணுது. Absorption and emission. Okay, now we'll come and see this. What is the meaning of absorption here? So that day itself we have seen on the basic. Before you are passing any energy, if you take the bulb, ordinary bulb, we'll go from the principle of ordinary light. We all know the source of the bulb, and the gundu bulb இருக்குல்ல, அதுல source என்ன யூஸ் பண்றோம்னா tungsten filament. Am I correct? Your tube light contains the filled with gases. Gases used as a medium. Here in this bulb we used tungsten as a medium. Okay, before I switched on the switch, before I pass the current to the tungsten filament, what about the tungsten atoms? You can see a small thin filament of tungsten on the bulb, and the thin tungsten filament, you know, it has a large number of atoms. All are tungsten atoms only. So before you are passing any energy to that tungsten filament, what about the position of the tungsten atoms? Does it excited mode or in the rest ground state mode?
Rest ground state mode.
Yes, rest. All the atoms, copper wire ko the same thing da. If you are passing, before you are passing the current to any devices, electrical fan, electrical light, fridge, any devices you are passing, before you are passing, all the devices are in the rest mode. The meaning is that the atoms use பண்ற the gas medium or a solid medium, and the medium உடைய atoms are in the ground state. So that is the level. You take the level as E1, lower energy state E1. Why we are dividing like this means we have to imagine all these things. We can explain only with the imagination only. So before I passing the current, before I am passing any energy to this tungsten filament, all the atoms are in the ground state. Tungsten atoms. These are all the tungsten atoms. The tungsten atoms are in the ground state. Now, when I pass the energy, suppose light energy or electrical energy na e power minus போட்டுக்கோ, electrons hit. இது h nu. If you are giving any energy to this atom, now you are switch on the current. When I switch on the switchboard, when the board is on, that now the electrons will passes through the wire, reaches the tungsten atom. The tungsten atom gains the energy from the electron and it excites. That is the state, absorption. So the tungsten atom gains. Gaining means absorbing. The tungsten atom absorbs the energy from the incident particle, even it is an electron or some photons, anything. ஏதோ ஒரு சோர்ஸ், டெம்பரேச்சர் கொடுக்கலாம், லைட் பாஸ் பண்ணலாம், or you can pass the electricity. These atoms or gains the energy, absorbs the energy and excited. We call this process as absorption. So what happens? The tungsten atom, before you are passing current, supplying the current to this tungsten atoms, the atoms are in the ground state. When I started to pass the energy, atoms in the ground state or absorb the energy and excited, goes to the level E2. Because depends upon the energy you supplied, these atoms can jump to the fourth level also, E1, E2, E3, E4. We call it as a solid, 4-level solid state laser. So it does not restrict itself to E2. These atoms will jump to level E2, higher energy state. Just for explanation, here we are using only the 2 levels. So the atoms jump from level E1 to higher energy level E2 by absorbing energy. We call it as the process absorption. Now we are going to write the equation for this absorption. Okay, that I will start. Okay, one more explanation I'll finish here. So what is the number of atoms in the ground state and number of atoms in the excited state? The number of atoms in the ground state is taken as N1. Number of atoms in the excited state is taken as N2. How to find the number of atoms in the ground state and excited state? That you use the Maxwell-Boltzmann statistics law. MB is given. This is the using this expression, Maxwell's Boltzmann statistics law. We will write N1 as N0 e power minus e by kt. What is N0? It is nothing but suppose this is taken as the lower energy state E1. This is taken as the higher energy state E2, and below this level, one more level we have to write, that is the ground state, that is the rest energy state. We'll take E0. The energy corresponds to this level is E0. The energy corresponds to this level is E1. The energy corresponds to this level is E2. Okay. Now we are going to the number of atoms in this level is N0. The number of atoms this level is N1. Sorry. The number of atoms in this level is N1. The number of atoms in this higher energy state is N2. So by using the Boltzmann statistical law, the atoms in this state gains the, can be find out. N1 is equal to N0 into e power minus h nu by kt. E power minus h nu, why I am telling h nu, E as h nu. See this, the energy we are passing, E is equal to h nu using Planck's relation. Okay, N0 is equal to N1. N1 is equal to number of atoms in the first level. N1 is equal to N0 into e power minus E1 by kt. The E1 என்றது தான் h nu. Okay, wow. So similarly, number of atoms in the level N2 is equal to N0 into e power minus E2 by kt. Go to this relation. So this will be substitute last at the end of this derivation. We will use this equation N1 and N2. This is Maxwell's Boltzmann law. How we will find it means it is the law derivation. This itself a bigger derivation. We arrived this using Maxwell's Boltzmann statistical law. We arrived this expression using this Number of atoms in the first level, number of atoms in the second level can be written. After we divide these two, n1 divided by n2 is equal to n0 e power e1 by kt minus e1 by kt, n0 e power minus e2 by kt. Na n0 n0 cancel ஆயிடும். சரியா? e2 when it's minus, a minus is missing on both equations. When this minus e2 comes to the numerator, minus will become plus. So this will become e2 minus e1 by kt. That is the next equation. n1 by n2 is equal to e power h nu by, what is this e2 minus e1 na? The difference between these two, e1 க்கும் e2 க்கும் இருக்கிற difference, by taking the e2 minus e1, this is equal to h into nu, that is the photon you supplied. e2 minus e1 is equal to h nu. So from this equation you can find out e2 க்கும் அந்த லெவலுக்கு இருக்கிற டிஃபரன்ஸ் வந்து h nu. That's why they have rewritten this expression as n1 by n2 is equal to e power h nu divided by kt. So now we will write the equation for the absorption. For the absorption, we call the stimulated absorption. So the number of atoms in the ground state, before we start the process, now the number of atoms in the ground state is more than the number of atoms in the excited state. After this delta E hits the ground state atom, this atom excited to the level E2. Now the population will start to increase at the level E2 because of continuous supplying of energy. Now write the number of transitions occurred per unit volume. The number of transitions occurred due to the absorption. Why we call it as stimulated? Why we use the word stimulated absorption here? Not a normal absorption. Just stimulated absorption means you are exciting these atoms. You are making it to excite. It's not automatic process. You are, after you switched on the current only, after you supplied the potential only, the tungsten atoms were excited. Without passing any energy, the atoms are in the ground state. The tungsten atoms are in the ground state only. So we are inducing the atoms to excite. The inducing is otherwise called as the stimulating. So the meaning of this process is stimulated absorption. The atoms in the ground state gains the energy, external energy, and excited to the higher energy level. This process continuously happens. So what is the number of transitions per unit volume? NSTAB is equal to, the number of atoms in the ground state is taken as N1 because atoms transferring from E1 to E2 only. The number of atoms in the ground state is written as N1. The Q is nothing but the energy was supplied, the energy required to raise the atom from the level E1 to level E2. Q is nothing but amount of energy absorbed by the ground state atom to excite to the level E2. எப்படி வேணாலும் எழுதலாம். So E2 to E1, that is Q. And B12 is the transition from 1 to 2, the constant to be included. Transition from level 1 to 2. What is the meaning of B12 is, it's the probability of transitions from 1 to level 1 to level 2. B12, E1 to E2. Take it as equation. Some equations were allotted. Okay, give it as equation number 5. So on the second, keep this equation. Now go to the second process. We all know this is not a permanent state. These atoms reaches the excited state is not a permanent state. Definitely it should return back. Okay. When it return back to the ground state, that is the second process. See this slide. On this, now emission takes place. It gains some energy. When it is in the ground state, these atoms gains the energy from incident photon and absorbed and excited. Okay, we all know this is not a permanent state. These atoms will automatically return back to the ground state with the emission of photon h nu. What the photon it absorbed here? what the energy it absorbed here. Suppose not your h nu, it absorbs the energy from electrons. That energy will be released in the form of photons of energy h nu from E2 to E2. E2. So what the question is here is any energy required to this atom to return back to the ground state? What I'm continuously speaking, speak something. Does the atoms require any energy to return to the ground state?
No, ma'am.
No, it automatically comes. It's sure. You are all very confident, no, that answer? Because these atoms does not require any energy to retain, because this is not a permanent state. So it exciter, it will stay some time, that means 10 power minus 3 seconds on that excited state. It will be, that is its lifetime on the excited state. That atom will return back to the ground state with emission of same photons. இங்க என்ன எனர்ஜி கெயின் பண்ணிச்சோ அந்த எனர்ஜி அது இங்க any form of energy it can absorb. Light energy, electrical energy, or thermal energy, any form of energy it can absorb, but it releases this energy in the form of light, the form of photons. It will be releases. It gains the energy from electricity. It gains the energy. The tungsten filament gains the energy from the electrons, but it releases light for us. It gives light whose energy is equivalent to h nu. That's all. The same thing, that is this first two diagram tells about the principle of ordinary light. And the tungsten filament gains the energy from electrons. Once I switched on, the electrons were sharing their energy to the neighboring atoms, and like that energy was shared. Finally, that energy was gained by the tungsten filament, and that tungsten atoms gains the energy and excited to the higher energy state. But after a few seconds, these atoms, tungsten atoms, will return back to the ground state with the emission of light. So namakku light kadachirichu room, we got the light in our room due to this process happens inside the bulb, ordinary light. Now we will go to the second derivation. Go to this part. It's a emission process, but we call it as a spontaneous emission. Why it is called as spontaneous? The first process is called as, Napa? What is the reason of spontaneous emission name?
திரும்ப திரும்ப நடக்கும் மேம்.
அதுக்கு பேரு வந்து திரும்ப திரும்ப நடக்கும்னு சொல்ல மாட்டாங்க. Only the difference I am telling here. Here these atoms move from level E1 to E2 due to the absorption of energy Q. Correct? The transition from E1 to E2 due to the energy Q only. But in the second process, the transition from E2 to E1, are you supplying any energy to this level? Any Q you are supplying to this
Yes,
excited atom?
No, ma'am.
We are not supplying any energy, but automatically the atom will be returned back. Once we excited, we are not in the excited mode. Definitely we should come back to the rest mode. That is automatic process. That is a spontaneous. That is called as the spontaneous process. It automatically happens in the atom. So we are not inducing the process here. It is a spontaneously. That atom in the excited state spontaneously emitted the photon when it returned back to the ground state. Now we will write the number of transitions occurring per unit volume in the second process. N S P E M. That is the N, number of transitions due to the spontaneous emission, is equal to number of atoms in the excited state, and the constant is A, 2 to 1. Transition from level 2 to 1. Does Q comes here? Compare the equation 1, this fifth equation with this. What is the difference between these two? One term is missing. Here we included the Q because these atoms absorb Q and excited. But in this process, atoms does not absorb any Q, but it automatically return back to the ground state. The transition automatically happens. So I'm not putting Q here. So your equation will be NSPEM is equal to, you can simply write NSP, that's all. NSP is equal to N2A21. We use the different constant because this is an spontaneous emission. We cannot use the same constant B. We use the constant A21. The 21 meaning is that transition from the level E2 to E1. And your third process is stimulated emission. Okay. Ordinary light can emit the photons h nu due to the spontaneous emission. But now we are studying the laser. I need high power light, high frequency light. The light comes out from that bulb should be in high intense. I need the high intense. So I have to induce more. I require more photons with the same wavelength, which are in coherency, with the same frequency, with high intense. So like that wave I required means I will enhance the process. And what way I am enhancing the process here? I am stimulating the emission. How I am stimulating? So when you see the first two process, this atom absorb 1 H nu excited, and the same atom return E1 with releasing 1 H nu. It absorbs 1 H nu, releases 1 H nu. But this is not sufficient for me because I am requiring the high dense wave, high intense wave. For many applications, I want this light for many applications, for communication purposes, for data readers, like that I want more applications. So I'm enhancing the process by stimulating this excited atom with one more photon, H nu. Now this atom releases two photons. Already it absorbed one photon here. This atom in the excited state is induced by one more photon. I am forcing this atom to emit two photons. See the difference between the two diagrams. This diagram, this atom releases 1 H nu. So this now in the diagram, this atom releases 2 H nu. So like that, all the atoms in the excited state will induce to emit multiple photons with high coherency. We call it as a stimulated emission. The forced emission of photons is called as a stimulated emission. Now we will write the equation for stimulated emission. See this? The number of transitions occurring per unit volume, NST, this is NST, is equal to number of atoms in the excited state N2, and B is a constant we use for stimulating, B21, Q. Why I am using Q? This atom in the excited state absorbing the energy Q. Okay, then only it releases two photons. One photon ல இருந்து இப்ப ரெண்டு photona release ஆகுது. See the difference. Now Q is absorbed. NST is equal to N2B21Q. So B21 is nothing but the number of transitions, a probability of transitions from level E2 to E1. Now we will assemble all the three equations in one equation at equilibrium position. What about the transitions count? The number of upward transitions and number of downward transitions. Does it same or different? The number of downward transitions and number of upward transitions. Two transitions you can study. One is due to the absorption, the atoms in the ground state are excited. Due to the stimulated absorption, emission and this spontaneous emission, the atoms are returned back to the ground state. We call it as a downward transitions. What about the count, the rate of upward transitions and rate of downward transitions, whether it is same or different? Any doubt? 4 atoms in the ground state. These atoms absorb the energy. Are you listening?
Yes, ma'am.
Okay. அடிக்கடி பேசு, இல்லைன்னா நான் சிக்னல் இருந்து வெளியே வந்துட்டேன்னு நினைப்பேன். These atoms gains the energy. இது ground state assume. See, one atom excited, that is upward transition. One is, I'll go to my paint. அதுதான் எனக்கு சிம்பிளா. So okay, suppose you have 4 atoms in the level E2. Okay, all these atoms are transferred from the level ground state to higher energy state. All will be, the 3 atoms will move to the higher energy state. This is, what is the number of upward transition now? What is the number of upward transition? These 3 atoms are excited due to the absorption of energy. These atoms are excited to the higher energy level. How many upward transitions you can see here?
3, ma'am.
3. Okay. How many downward transitions are possible for this diagram?
3, ma'am.
3 only. So what is the meaning of number of upward transition is equal to?
Number of downward transition.
ஆமா, number of downward transitions. Excite ஆன atoms தான் ரிட்டர்ன் ஆக போகுது. அடிஷனலா எந்த ஆட்டம்ஸுமே இங்க கிடையாது. அவ்வளவுதான், சிம்பிள் திங். அதுதான் கேட்கிறேன் திரும்ப திரும்ப. So at equilibrium, the number of upward transition is equal to number of downward transitions. Only one equation for upward transition, this one, and there will be 2 equations for downward transition, this NSPEM and NSTEM. 3 equations are written in one equation format. Write Q terms in one side. Only the 2 terms have Q. The first, this upward la onno, downward transition la or Q irukku. So write, bring N2A21 is equal to N1B12Q minus N2B21Q. Okay, write N2A21 is equal to this minus this. Take Q outside the bracket. N2A21 is equal to N1B12 minus N2B21 into Q. So Q is equal to N2A21 divided by N1B12 minus N2B21. Simple mathematical shuffling only. Just you rearranging the terms. Once you have written the upward and downward transitions or in the single equation, Q are all taken in one side. Other term will be kept at one side. So that Q is common, right outside the bracket of the 2 terms Q. So what is Q? Just you bring it to the denominator of N2A21. Okay. Now Q is equal to N2A21 divided by N1B12 minus N2B21. Divide the numerator and denominator by N2B21. இங்க இருக்கா N2B21? Equation 6 la you are finding this N2B21 here. Okay, divide this N2A21 by N2B21, N1B12 by N2B21, and this again by N2B21. N2B21 will be cancelled. You will be getting only 1 here. I will go to the next slide. N2B21 divide பண்ணும்போது இங்க மட்டும் ஒரு 1 கிடைக்கும். When I am dividing this term N2B21, I am writing here. N2 is again getting cancelled. Everything is max only. N2 is cancelled. After cancelling, A21 by B21 only left out. So the remaining term is 1 by N1B12, N2B21 minus 1. So Q is equal to N2, A21, B21, 1 divided by, the N1 by N2 is nothing but, already before I start this derivation, we have derived the number of atoms. N1 by N2 is equal to e power h nu by kt. That has to be substituted here. Where? This equation. n1 by n2 க்கு பதிலா e power h nu by kt substitute பண்ணிட்டு போடுவோம். So q is equal to, this is nothing but the same energy equation. We use it from Planck's radiation law. This equation we derived from your fourth unit. In your fourth unit we derived this equation. Q is equal to 8 by h nu cube. இது ஒரு பெரிய derivation தான். 8 by h nu cube divided by c cube 1 by e power h nu by kt minus 1, using the black body concept. Black body is nothing but a body, any body coated with black color will absorb all the right radiation falls on it. A black body radiation concept Planck's radiation law la padichirupom. Okay wow, what is the energy absorbed? That is q is equal to 8 by h nu cube divided by c cube. Nu is the frequency of light, c is the, what is that, c, velocity of light, 1 by e power h nu by kt minus 1. Both will be the same nu only. Okay, this we are directly taking here. Now compare these two equations, this 7 and 8. Compare it. Compare these two equations. By comparing these two, see the equation 7 and 8. On this equation 7 and 8, see the terms parallel to one another. These two terms are appear to be same, and these two sets are to be written separately. So from this equation, A21 by B21 is equal to 8 pi. By comparing this 7 and 8, A21 by B21 is written as 8 by h nu cube by c cube, and these two terms are to be written. Now compare that, like that you compare. Now tell me, what is B12 by B21?
1, ma'am.
1, simple, that's all. So by comparing this equation 7 and 8, A21 by B21 is equal to 8 by h nu cube by c cube. B12 by B1 is equal to 1. Here only 1 is there. We have to assume 1 is there. In place of B12 by B21, we will take 1. Okay, 1 multiplied with e power h nu by kt minus 1. So B12 by B21 is equal to 1. But A21 by B21, both are ratios of emission process. This is spontaneous emission. This is stimulated emission. Which one? A21 is the spontaneous emission. B21 is the stimulated emission. So what is the meaning is that A21 by B21, the emission completely depends upon the frequency. Other terms are all constant. 8, pi, h, c and all constant. Okay, so from this relation, we can identify that the emission purely depends upon the frequency of the light radiation. And B, from this equation, you say B12 by B21 is equal to 1. If these two is equal to 1 means B12 is equal to B21. The meaning is that number of upward transition is equal to number of downward transitions. That is equation 10. That's all. Any doubt? Einstein's A and B relation. It's another important derivation in this unit. What is E? Are you having any doubt?
No, ma'am.
Ma'am.
No? Well cleared?